Night. Thank you everybody so much for coming. First up, we're actually going to have one of my students, Gokul. He did the security camera project and he was very amazing at taking initiative and making his own modifications from the very beginning, from connecting it to a bigger display, modifying how the infrared sensor was connected, and even now working towards adding a buzzer sound. So that his motion detector doesn't just record video, but it will also play an alarm when triggered. And so today he's going to be showing off his infrared sensor and camera because he has a fully working base project and he did a really amazing job on that. So I'm going to go ahead and turn it over to him so he can tell you more about it.
Um, Hello, my name is Gokul. I go to Mountain House High School. I'm a sophomore, and yeah, my project is the security camera. So, how it works is that there's a motion sensor, and then whenever motion is triggered, or whenever a motion is detected, it triggers a camera module, and then the camera module records footage and then stores it into the Raspberry Pi. And okay, and I have can I share my screen now?
Of
Of
course.
course.
Um, Apologies if it's a bit blurry. Um, so yeah, here's the Raspberry Pi. This is the camera module, and this is the motion detector, the infrared sensor. Okay, now you were able to see this, right?
Yes.
Um, so yeah, this is all of the code. This part is importing all of this stuff, and these these are the variables. Uh, the PIR is the motion sensor. PyCam2 is the camera module, and the encoder is the H.264, and the output is the file name. So for this part, the motion sensor waits for motion. It prints motion detected, and it also prepares the file name, which would be the year, the day, the date, and the exact time. And then it configures the camera, and then the camera starts recording. And then when there's no motion left, the camera stops recording and it prints no motion detected. So, see, motion is detected right now, and now there's no motion detected. And then, if I go to files, that's the file name. It has all the information on it. And then, yeah, it records everything. So, a lesson I have gained through this project is that if I'm struggling, if I'm stuck on something, then I just have to persevere through it and work through it. And I picked my project because I was interested in working with a Raspberry Pi, and I also wanted to learn some coding skills. I had no coding skills prior to this project. Any questions?
I have a question, Gokul. My question is, clearly with your project, there is a heavy emphasis on computer science and like the integration of many different systems. So that's your PC, that's your Raspberry Pi, and that's your camera system. So how did this project kind of deepen your understanding of computer science or challenge any notions of computer science that you previously might have had?
Well, it really it really just taught me the basics of computer
Mhm.
science, like how the computer actually works, and how to just operate a computer properly. And yeah.
Thank you. That was a good answer. Does anybody else have any questions? Okay. If not, we'll move on to the next student. Caesar is next up, and he's a student of mine. He is a student who had a generally unorthodox approach to the Bluestamp engineering experience. He originally pursued a International Space Station tracker as his project. However, due to some technical difficulties, we had some issues with interfacing that with interfacing the hardware with his MacBook. So instead, Caesar kind of initiated a pivot to a more environmentally conscious project in which he tracked the biodiversity in certain areas of the world and plotted them on a certain type of map called a choropleth, which I'll explain soon. And I'm incredibly proud of Caesar's progress because he entered Bluestamp without any prior knowledge of coding or computer science, and he built basically from the ground up an extremely detailed and a heavily detailed and strong computer science based project. So without further ado, let's give it up for Caesar.
Right. Hi, good afternoon. My name is Caesar, and for this project, and I go to Cape NYC College Prep. I'm a rising senior, and my project is the Biodiversity and Natural Disaster Indicator. So for this project, I basically made a LCD, or I'm sorry, a choropleth map that is supposed to showcase to be seen in my LCD display. So for this project, it showcases the biodiversity in like different countries around the world. So let's say France, for example, and you can see that the percentage of the protected areas is 33.2% compared to a country that is yellow or light green. It has a 0.3%. And I'm going, I'm gonna show my screen on like my other project that I made, which was the International Space Tracker. So this is what a part of my code for my original project. So for my original project, I basically did this mathematical equation to showcase the latitude and the longitude of the International Space Tracker, which showcases like where the space tracker is currently in the world, and it showcases like the movement or like over an hour. And this is a this is a this is my code from the project that I'm currently done with, which was the choropleth map. And then for this project, I use pandas to load the data and Plotly to create a interactive map, which is the map that I showed earlier. And I wanted to mention how for this project and for a challenge that I faced was the amount of technical difficulties that I had. At first, I did not have a adapter which was supposed to connect to my ra- to my um to my Raspberry Pi, and then I had like a bunch of other technical difficulties. And the reason why I joined Bluestamp was I knew that I wanted to do something in engineering, but I did not know what type of field I was interested in. So I like was leaning into like mechanical engineering, but with all the technical difficulties I made a new project, and it was like something I was more interested in, which was the biodiversity and natural disaster indicator. And I think that's something that like I learned from Bluestamp, like the amount of technical difficulties. Um there's always like an alternative way or a path to go to, like if things don't go right. And yeah.
Thank you. Are there any questions for Caesar? Okay, I have a question for you, Caesar.
Yeah.
So it seems like a common theme between your two projects was kind of this emphasis on maybe the earth or like the environment in general,
Yeah.
right? So how would you describe your progress or attitude towards like environmental engineering or things that pertain to measuring parts of the earth as a whole as part of the Blue Stamp experience?
So, going into like these like different projects, I feel like It was basically like my both of the projects really were leaning into like the environment, and I think going into Bluestamp, I can take this project and say that these like two projects can be used to like showcase like the how like the world uses like its resources in like certain ways. So yeah.
Awesome, thank you. Are there any other questions for Caesar? No? Okay. Well, next up we have Kang. He's a student who is actually currently located in Vietnam. So actually the remote program was the only way Kang would be able to experience the program. And because of his location, we've had difficulty shipping components to him. So he's had to be resourceful with the kinds of modifications he could make to his project, which was the gesture controlled robot. And Kang is a student who is incredibly diligent in his work. He consistently shows up to innovation lab for uh, acceleration for his project, and it really shows in the output of his work. So let's see what Kang has to present for us.
Uh, so hi y'all. My name is Kang. I'm from the European School in State, California. So my main project is hand gesture control robot, but I modified it to be kind of like a RC car. So I'll show you guys right now. So that's now. So I'm holding controller. I put this up. It's moving. Yeah. When I turn right, it's turning right. Okay. So and that's the modified project, and I'll show you guys my base project too. Please give me a moment so I can present. So here's the car when I use the motion. You can see when I move my board, it also moves the car too. Yep. So the way that like the system work is that I have two brain for the hand component and the car. For the car I have Uno and for the hand I have the micro. They kind of talk to each other. So so the Uno, so the micro send information over for the Uno. So those package of information is including where to go. So then the Uno is gonna use those information to send to the motor driver. Then with the energy it has to turn the motor. And how the way that like I send the information was I have the two Bluetooth module HC05. They're connected together like father and son. So when I turn them both on, they're gonna kind of like look for each other, and then they're gonna connect, and then they're gonna trade information. Um, so for the modified project, I use the joystick. It basically track like it's gonna send back the information how far am I moving the joystick so I can determine like which way I'm trying to move my car. And for my basic project, I use MPU 6050. It's basically accelerometer, so it's gonna measure how far I'm moving my hand off the dead zone, so I can determine the same way that like I use it for the joystick. It was very challenging, connecting the two Bluetooth module because sometimes they are very inconsistent and like sometimes they send wrong packages. But I learned a lot from be able to how to debug and as well as like wiring because it's a pretty complicated wiring for me because it's like real my first time wiring, but like it's very fun and like good way of me to learn. I think I joined BSE because I'm very interested in mechanical engineering, and I when I see this car on the BSE website, I need to like I gotta do this because like I'm a car guy. I love building car. It's my dream since like 5 years old to build my own RC car. So I think after 10 years, I achieved my dream now, and it was very fun joining this program. Thank you.
All right. Do we have any questions for Kang?
I have one. So how did you end up deciding on the RC car modification? Because I know that there were some part limitations, so how was that able to become a reality?
So they actually sent me the whole three joint arm robot, like the whole extra. I just took the joystick from the arm and like bring it to my car. That's what I did.
Cool.
I also have a question for you. You mentioned that it's your dream to work as like an automotive engineer, right? So how did working on this project as like a mini environment for cars kind of influence your opinion on wanting to pursue automotive engineering?
I think it's really strengthened my opinion to be automotive engineering because it's very cool, like knowing like how to the system work and how to organize it in the way that like it can work the most efficient way and most like smooth way.
Yeah. I think that's a really important thing that you learned and is really applicable to automotive engineering. Awesome. Anybody else? Okay. Thank you, Kang. Next up, we have Benjamin. And Ben is one of our younger students at Bluestamp. He's going into the 10th grade. And despite that, despite having taken fewer classes and being younger in age, he's pursuing the same project that a lot of the older students at Bluestamp are doing. And he's made really great strides in the progress in not just the mechanical component of his arm, but also the computer science aspect. He came into Bluestamp knowing a little bit of HTML, and he sought to utilize that in his modification that you'll soon come to realize. And I will let Ben's project speaks for itself. So without further ado, take it away.
Hi, my name is Benjamin. I'm a rising 10th grader at Northwood High School. And for my main project, I chose the three-joint robotic arm, which is controlled by four servos. So like one over here, one over here, one here, and one to control the base. And it is controlled by a joystick that basically on each axis of the joystick control a certain part of the arm. So here's like a quick demo. Yeah. And I modified this project by using a ESP32 to create a web server that basically allows me to read the angles from the servo on the robotic arm. And okay, I'm gonna share my screen. Okay, so
Yeah, that's good.
as you can see, when I turn my joysticks, the page updates to where it is. So there's a quick example. Uh, this created this modification uh, gave me more challenges with learning new things like having a voltage divider because the Arduino Nano ESP32 couldn't take in the 5 voltage. And it also helped me learn things like new coding and how to create a web server. I chose this project because it combines hands-on building along with coding. And what I learned from Bluestamp was that research is probably the best way for me to troubleshoot problems. And Bluestamp also helped me with the fundamental understanding of coding. Okay, that's it.
Awesome presentations, Ben. Thank you for sharing that with us. Does anybody have any questions for him?
I have a question.
Sure.
So having a website set up to like interact with robots is really, really cool. Do you have any ideas for like next steps you want to do having this interface now set up?
I mean, I don't know if it's possible, but maybe I want to have it actually control the servo.
Like
Mhm.
having like a bunch of buttons set up?
Yeah, like maybe I was thinking like sliders, like
Oh,
yeah, control the angle, but I don't know if that's too hard.
Ben, I really like that question you asked at first. I don't know if it's possible. That's a question that is often asked in engineering and is honestly like the most underlying and fundamental question of engineering. So, like you asking that question is it's such a testament to how much you've learned at Bluestamp as like in terms of adopting that engineering mindset. And the answer to that question is yes, of course it's possible, because you can make it possible. Thanks for sharing that, Ben. Anybody else? Okay, I think we're ready for the next student. I think that's one of Julia's.
All right. Yes, so we'll have Tria going next. She did the Smart Mirror project, and she actually finished the baseline project extremely quickly, even though she had an issue with an SD card adapter at first. And because she finished so quickly, beyond just getting the mirror modules onto the display, she actually worked out a camera feed on the display as well. And that ended up being a pretty complex and intensive modification. So she learned a lot about troubleshooting, a lot about software, and I'll let her take it away to show you her project.
Hi, I'm Tria, and I go to Foothill High School, and I'm an incoming junior. And so my project is the Smart Mirror, which acts like a personal assistant, and it shows a live camera feed to act like the mirror. And it also shows different modules, which you would find on your phone, like a calendar, the time, reminders, etc. And one of the biggest challenges I faced was getting the mirror feature from the camera and the modules to run simultaneously. And that's an issue which is ongoing. However, I was able to get both of them to operate separately. So I have two videos I can show of that. So this is the smart mirror with the modules. So there's a complement, there's the time, the calendar dates, and this is a modification I added, which is a reminder for medicine. So that's, and this is the live camera feed, which I got working. And yeah, the window size is small because otherwise the stream doesn't work efficiently. Yeah, and um, um, yeah, so I was able to get both of the parts working separately, and I think a lesson that I learned was the importance of perseverance and patience and kind of hope as well, because I was definitely losing hope at one point, but there is always a solution and a workaround to all the problems that come up. And I joined Bluestamp since I have an interest in engineering, but I didn't necessarily know which direction I wanted to go in. And through this program, I learned how to connect like software and hardware together, which I think is really important for engineering. And yeah, thank you.
All right. Does anyone have a question for Tria?
I have a question.
All right, Everest.
So, what were the steps that you had to use to get to the camera, the sort of camera feed to play back in the Magic Mirror? It seems like that was a very, very involved sort of modification.
Yeah, so I had trouble from the start with the hardware, because it's really delicate, like the clip on the Raspberry Pi. It took me like 20 minutes to just get the camera module thing in, so I had to press like one side at a time. And then getting the software connected was also really difficult. But eventually, I think after moving my code to VS Code instead of Linux, it was a much easier process. And yeah, with like Julia's support, I was able to get that working.
All right, thank you.
Let's see.
All right. Does anyone have any more questions for Tria? All right. Well, thank you for presenting. Awesome job on your project.
All right, next up, we have Kobe. Now, Kobe also pursued the three-joint robotic arm similar to Ben, and he, as a modification, he decided to do something very mechanically oriented. And that was impressive to me because this is, of course, a remote program. So there's only so much that I, as his instructor, could do to physically assist him. So his complete milestone is truly a testament to his own self-reliance and his own ability to solve problems and think critically without additional support. So without further ado, take it away, Kobe.
Hi, I'm Kobe. I go to Sage Creek High School, class of 2027. This is my base project, robotic arm. And basically how it works is these joysticks send integer values to the Arduino code on my computer, and these values correspond with the X and Y positions of these joysticks. And then once they hit a certain threshold, depending on the value, it will tell the servos to increase or decrease by a certain angle amount, which will then tell the servo to turn in certain directions. And then for my modification, I decided to turn it into a claw machine. This is like the prize area. And then here is where you drop it off. There are two outcomes. I have my little cousin Joshua demonstrate in some videos. Joshua, you want to say hi?
Hello.
Hi.
And then I could share my screen. So if you drop it in the right, it will return to the main area and you lose. And then drop it in the left side. It'll drop off and then you win your prize. Some challenges I faced during this project was the arm was actually not able to grab anything at first. So I kept making new designs for the claw using different materials like plastic, cardboard, all of that. Nothing seemed to work, but I did find a common error that that was that the claw kept like jittering, opening, closing every time I tried to move it up or down. So I concluded that it was a coding limitation. So basically, the code, since there was a candy in between, it confused the arm because it thought it was more closed than it actually was, so it started to spaz out. So to fix this, I had to change the library. I had to change the code library and limit the value to only close to a certain amount so it could actually pick the candy up. I joined Bluestamp because I wanted a hands-on experience, and then Bluestamp's flexibility was very appealing to me because I was very interested in how they could execute such a hands-on program virtually. And I chose this specific project because I wanted like a little mix of mechanical and coding. And then something I learned from Bluestamp is that even if you're completely new to something, you could apply like existing knowledge to aid you on your journey because I was completely new to C++, but I did have some Python knowledge. So once I understood the syntax of C++, I was able to code more easily. That's it. Thank you.
Yeah. Awesome presentation and awesome demonstration. I appreciate you bringing your cousin into this. Anyway, does anybody have any questions they want to ask Kobe? I'll ask a question then. You mentioned being able to complete the modification only by editing a library. What is
Yeah.
a library and how did you integrate it into your project?
So the libraries are basically pre-made codes that you can incorporate in your main code just to make it a little easier. And then I incorporated these by there's an include command. So once you have your library downloaded, you could just call it by executing the include command.
Awesome, yeah. Seems like you learned a lot about computer science. Anyone else?
I have a question.
Yeah.
Have you tried your claw game with other types of candy yet?
Not yet, but I was going to.
All right, cool. Interested in seeing that work out.
Anyone else? All right. Well, I will hand it over to Julia now.
All right. And I love the approach to user research and user testing by getting your cousin involved. Yeah, definitely cool thing to do for human computer interaction. Next up, we have Akshita, and her project was already complex to begin with, as it's a storybook that generates stories based on an input prompt through ChatGPT. And then her project was made more complex by some early software difficulties with getting the operating system onto the Raspberry Pi, and then further difficulties that essentially meant she had to restructure the entire project, restructure the package management for it, and do a ton of intensive modifications, even really before the base project was able to be completed. And so she spent a ton of extra time in Innovation Lab working through it, learned a ton about troubleshooting and debugging, and really persevered through a lot of challenges to come up with an awesome project. So I'll let her tell you more about it.
So I'm Akshita, and I'm a rising senior at Mountain House High School. So my project was a ChatGPT storybook, which what basically it did was that it displayed like a AI generated story based on input given by the user. So this is the display system over here, and this is the Raspberry Pi, and like this is the homepage. The and what it did was you typed in like um your prompt, what you want your story about. All right. And then what you did, and then you hit enter, and then it sent it to ChatGPT in order to create a story. And it then received the story and displayed it. And there was like buttons like the next and back button, and along with like which helped you navigate it to through the story. And there was like also a plus button which allowed you to create like a new prompt. So some challenges I faced regarding like my project was about my libraries, which at the beginning didn't really work. Like my code was saying they weren't found. So what I had to do was I had to manually install them in the terminal. And at first, I tried installing them using pip. However, that did not work. So I had to go use a better navigator, which then I went to Anaconda. But the thing about Anaconda is that it didn't support Raspberry Pi. So I switched to Miniconda. And once I installed Miniconda, I imported all my libraries manually when another problem came up. So there's this library, it's called speech recognition, and it's used for is it's used for like listening to the user input. When like the user says their prompt, it will listen to it. However, that library didn't import for me because of the Python version I had. I had like Python version 13, while the library could only support with Python versions 10 and 11. So what I had to do I had to switch it to like keyboard input. So in order to, and that like changed, that like took away like a huge portion of my project, which I had to rewrite. So at first I tried creating a keyboard through Pygame. However, that didn't work. So we decided to like switch it to vKeyboard library, which was more successful. And through all of this, I learned how to persevere through challenges, as well as like how to utilize my resources in order to solve any like coding or software problems I face. Another thing I learned was how like command prompt instructions and key terms, which like such as CD and Nano, which gave me a more of like an understanding of how the command prompt works. And I joined Bluestamp Engineering in order to like gain an understanding of how engineering worked, as well as introduce myself into the field and think my project.
I have a question for you, Akshita.
Yeah.
So, you were not my student directly, but overhearing a lot of conversations with your instructor and Everest, there was a lot of debugging going along, right?
Yeah.
So my question was, what are some of like the most effective debugging techniques that you've learned from Bluestamp, and how do you think you could utilize them in the future?
I feel like the most effective debugging is like going through Stack Overflow, which is like a website. And because like that's actually a very helpful website that gives you solutions based on like what other people face. So you have ideas of how to proceed with your problems.
Awesome. Thank you so much.
Any other questions?
Yeah, Stack Overflow is the best.
It's
And
basically an
yeah,
industry standard.
yeah, Stack Overflow is amazing. And yeah, as your instructor, I know you faced a lot of challenges and debugging moments. What were some of your favorite things you learned or breakthroughs that you had?
I think my favorite part was getting like the code to completely work.
Yeah,
But
no,
another
that's
thing,
very satisfying.
yeah, but another thing was when like the library is fully imported, all of them.
Definitely. Awesome job. So yeah, I will go ahead. Or are there any other questions? All right, I'll turn it back over to Josh then.
Thanks, Julia. All right, next up, we have Anakshi. And Anakshi came into Bluestamp without having done any prior engineering, but wanting to get a taste of it, she wanted to get a taste of it all, right? And you can see that she really, really, really got into the wiring. She got into the computer science element, and she kind of got into the mechanical aspect a little bit. And I'm incredibly proud of the progress that Anakshi has made from knowing almost nothing about engineering to being able to write her own HTML code, her own C++ code, learning how to wire a bunch of different components. She learned a lot about transmission protocols between components and microcontrollers. And overall, it's just the general breadth of all of her modifications is truly something to marvel at. So, without further ado, let's hear from Anakshi.
All right, hi, I'm Anakshi. I'm an incoming senior at Amador Valley High School. And my project was the biometric pulse sensor. So, okay, we've got different components here. This is a fan. This is your actual pulse sensor. You attach it to your finger and it senses your BPM. And then we have an LCD monitor here. It'll actually tell you what your BPM is. And then the other two components, there's a breadboard for all of the electrical wiring, and then the black portion, that is a module where all your code goes through. So that is basically my base project. And then from there, my modifications, I first started when I had my base project fully done, it was giving me weird like it was sensing my BPM was like 900, which is completely abnormal, not normal at all. So I was like, okay, let's turn this into something fun. So my first modification was an LED heart, if you can see over here in the red portion, when my BPM is under 100, which then was abnormal, then the sensor says that my BPM is a winner, and then the LEDs light up. And then after that specific modification, I was actually able to fix the issue. The issue was there's a specific variable called a threshold, which is how it is able to sense my BPM, and that threshold was too high. So after a little bit of adjusting, I got it working. So then after that, I was like, okay, let's do another modification. So my second modification is the fan. So when my BPM is over 180, the fan runs. And I chose over 180 because typically that would mean you've been working out and you'd probably be hot. And then my third modification is I used a Wi-Fi module, so this thing over here, and that connects to a website in which I can keep a history of my BPM. So this is, here we go. Yeah, this is what it looks like. Yeah, so that's my project. I joined Bluestamp, like Josh said, I wanted to get more experience with coding. I'd never done coding like in this sort of depth before. And then I also wanted to explore engineering as a whole because I know that's what I want to do in college. And then I chose this specific project because I wanted to have something that would be really useful in my daily life, and also something that I just found interesting. So yeah.
Awesome. Thank you for sharing, Anakshi. Does anybody have any questions for her? Well, I have a question for you, Anakshi. Like I described before, your project encompassed a lot of components of engineering and a lot of different aspects that you kind of combined together into one amazing project. So, if you were to pick one, what's your favorite component of the project that you built, and how might you think you want to pursue that field at a later time?
Ooh, I like a lot. I like all of my modifications a lot, but I think the one that I want to expand on is the website because right now the way it works is I have to manually input my BPM history. And
Mhm.
what I'd like to do in the future is learn a little bit of JavaScript so that way I can actually get like the BPM data live.
Awesome. Thanks so
Uh,
much, Anakshi. What's up, Everest?
I have a question. So, like medical health stuff is very, very, real in the real man. But man, human lives are real in the real world. Crazy. But what I'm meaning by leaning into that is like, do you have any sort of ideas about how you would want to apply a project like this into your daily life? You mentioned maybe using it daily or regularly. So, what are your thoughts about that?
Yeah, so I particularly like this project because I can interact with it like on a daily basis. I feel like for me, robotics have never been my thing. I prefer something that I find more useful for myself. So I feel like this project kind of gave me a little bit more insight as to what I like, whether it be biology related engineering in the future or something else. I feel like I want to do something that kind of helps people in a sort of way. So.
Awesome, thank you.
yeah, this project actually reminds me a lot of a common sensor in medical settings that gets pulse and like oxygen saturation. So have you thought of other sensors or other devices you might want to add to this?
Oh, while I was doing my modifications, I was actually looking at there's a temperature sensor in my kit. I initially thought I wanted to use that as like a sort of thermometer. Unfortunately, it only senses like environment heat, not human temperatures, so I couldn't use it, but that would be something that I could certainly think about.
Cool.
All right, next up we have Scott. And there's a lot to say about Scott. His project modification was definitely a buzzer beater. We got to complete literally this afternoon, which I'm incredibly proud of Scott for completing. And my favorite thing about Scott is just how much he perseveres and how much he wants to be self-reliant and find his own path through conflict. We encountered a lot of issues with some of the components in his project. And anytime that I asked if he wanted my support, he always said, "No, I want to figure this out myself." And I truly, truly admire that about Scott. Additionally, anytime that we made a major breakthrough, because he was so self-reliant, he had the hugest smile, and I can just tell he has a really, really deep passion for engineering. So let's see what you have to offer, Scott.
Okay. Hello, my name is Scott. I'm an incoming junior at West Torrance High School. My base project was also the three-joint robotic arm controlled by joysticks. My modification was to separate the joysticks from the main part of the robotic arm and use two HC05 Bluetooth modules. This is one of them, and then here's the other one to send commands between them. Um, so how it works is basically the joysticks continuously send values to this Arduino, which translates those values into single character commands. Then this HC05 sends those single character commands to my other HC05 that's connected to my arm. Um, and then those commands go to another Arduino, which uh, turns those single character commands into commands that make the arm open, close, move up and down, and turn left and right. And then I'll demo it right now. It's kind of jittery, but that's just kind of how it works. Okay. And I can get up and move around when I do it because it's Bluetooth, which is I think is really cool.
Oh my gosh, there it goes.
Something with Bluestamp was that I got a really good foundation in coding, which I hadn't done much of before this class. And another thing that I learned was that even if you're putting a lot of work into something and it isn't working, the best thing you can do is get someone else to look at the problem. And if you can't think of a solution, they might. I also learned that even if it doesn't seem like you're making any progress, keep working because if you're consistent, you'll probably find the answer. And when you do, it'll be all the more satisfying because of the work you put into it. I joined Bluestamp because I wanted to get an intro to coding and because I wanted a more hands-on experience in engineering this summer. I chose the robotic arm as my project because I want to do mechanical engineering later in life, and it highlights things I definitely will need to be familiar with, such as coding, electronics, and physics. I think it went really well, and I like how my project turned out. Does anyone have any questions?
Yeah, I've got one. So you mentioned how coding, electronics, and physics are going to fit into your overall goal of being a mechanical engineer. What are some projects that you could see yourself doing in the future that combine those aspects?
I think it would be really cool to work on planes and aerospace stuff when I get older. That's just something I've always wanted to do. My dad works at Boeing, and I just really like physics. I like mechanical engineering. I like planes. I think that'd be really fun.
One question that I have for you, Scott, is you certainly were in the thick of it, in the debugging process and coming with the modification and everything. So how do you think you've learned to improve your critical thinking ability to work through these struggles as an engineering student?
I've learned that I've definitely learned for sure that little tiny mistakes can have huge consequences. Um, like if you just have one wrong character in your code, it can mess your entire thing up and you won't know unless you go look for it. So I guess I just learned that you have to be really careful with this kind of stuff. And if something goes wrong, if you were careful while you were putting it together, if something goes wrong, it's probably not a huge issue. Um, and it's just a little error that you need to look for and find. And once you correct it, it'll be totally fine.
Yeah, that's a really great and insightful answer about like the compounding potential of small mistakes. And that's really important to keep in mind as an engineer, and even more so as an aerospace engineer, where, all your aircrafts are thoroughly checked. If even one screw is missing, it's over for you, you know?
Yeah.
I'm sure Julia knows she's pursuing aerospace, right?
Yeah, that was why I was like thumbs up reacting. Like
Yeah, yeah.
that is really cool.
Mhm.
Um,
Does anybody else have any questions? Quiet audience today, I must say. All right, all right. Last but certainly not least, we have Hebe, who is clearly a busy young woman. She's coming out of some sports practice, trying to present this. And Hebe's journey is similar to a lot of students in which she develops a lot of breadth as well as depth in understanding her project, which is really important as an engineer to both have that expansive toolbox to draw from and also that really deep-rooted knowledge in one particular area. And I saw that growth as this quote unquote T-shaped engineer with Hebe, through understanding how all of the components in her project fit together, as well as deeply how she understood how to code each individual thing, and especially with her modification, which she sought out and found her own libraries to integrate as part of it. So, without further ado, let's hear it for Hebe.
Hi. Obviously, I'm not at home right now, but um, hi, my name is Hebe, and for Bluestamp Engineering, my final project, I built a human-following robot that can detect and follow objects, as well as avoid obstacles, display live feedback on the LCD screen, and even play music all at the same time. Wait, you guys can hear me, right?
Yeah.
Okay. So for the core of my robot is the Arduino, which basically acts as the brain of the entire system. It reads sensor data, makes decision, and sends data points out. I have an ultrasonic sensor in the front of my robot, which is connected to the trig pin and echo pin, and it basically sends out sound waves and listens for echo to measure how far away an object is. There are two iris sensors mounted on each side, which detect reflected infrared light to determine if something is close to the object, and it can make the robot turn accordingly towards the object. My robot basically used the ultrasonic sensor as demonstrated in the video to follow objects between 5 to 15 centimeters away. If an object gets too close, which is around like under 5 centimeters or above 15, it stops to avoid a collision. When there's no object in front of it, it turns into its infrared sensors, which is basically iris sensors, one on the left and one on the right to detect walls and your hand, and it will turn accordingly to it. And the robot moves using two DC motors, I believe, and which are connected to the motor driver pins on the Arduino. By using analog write to send pulse width modulation signals, the Arduino can adjust motor speed and direction. And for example, if the robot needs to turn, it slows down one motor and keeps the other running for it to make a turn. I also had two modifications in this product. In this project, I had the LCD screen, which is connected via I2C, and it constantly updates the user on like when a robot is turning, when it's stopping, and when it's not moving. And it also detects the distance between the object and the hand. And at the same time, I also have a buzzer which is connected to the pin 11 on the Arduino, and also um to the a ground pin, and it basically plays a melody in the background. You guys can play it later, but I think it should play the Never Gonna Give You Up by Rick Astley in the background. Oh yeah.
I can press this video before something.
Yeah, it does that. The biggest challenge I faced while building this project was definitely the managing the wiring. There were so much components like motors, sensors, and LCD. There was a buzzer, and it was all connected to one Arduino. So it was like if you were one pin off, it definitely like messed up the entire thing. So that was like the biggest challenge I faced. And the troubleshooting really taught me that you had to be really patient, and you had to understand that like even if there's one pin off, like the robot might not move at all. So that really taught me something. This was definitely one of the first projects I ever done like related to engineering, which is why I decided to pursue Bluestamp in the first place. I had a lot of science background, like I took AP Chem, AP Bio, and also AP Calc BC, but I never like done anything like physics related or like engineering related. So this is definitely a first time. And it also taught me that patience and determination was definitely the key, and like being able to push through was definitely like helpful, and it really taught me how to like adapt or learn code like C++ really easily. And yeah, thank you.
Awesome presentation, Hebe. One question that I have for you is, you mentioned wanting to pursue this program at Bluestamp as kind of like an extension or an application of your background in science and math. So how do you think your experience with Bluestamp kind of facilitated that connection or challenged that connection?
um I don't know, I feel like Bluestem was a lot more hands-on. Like your question was like how does like Bluestamp like further that connection, right? I
Yeah,
thought
or challenge it. Go
because
on.
I feel like for the sciences or like the math that I took in school is vague. It's like vastly different. Like I took a lot more conceptual, like science, more conceptual math, kind of. Like for biology and chemistry, it's a lot more like about molecules, about atoms, about like how life works. And I really liked how hands-on like Blue Stamp was. Like I got to learn code. I got to build robots. I I learned C++ plus plus for the first time. I had going to this program, I had no idea what even Arduino is. So it was like a really different experience, and it really like I don't know, it made me like more excited in what I want to pursue in the future and what I want to major in when I do apply to college, because I am a rising senior at this moment.
Well said. Thank you, Hebe. Does anybody else have any questions? It's your last chance to ask questions to our wonderful Bluestamp students. Come on.
Yeah, I was just interested. What sport do you play and how much did it affect your time at Bluestamp?
Okay, I play, well, I do like a bunch of sports. I run state for cross country. I've done volleyball for club.
Mhm.
I actually just came out paddling. So I'm team USA for paddling too. So I'm going to Germany and I'm racing a world in like 1 week. So yeah, I also
Well,
do track and field too.
well, we wish you the absolute best of luck in that competition.
Thank
Wow.
you.
So glad you're able to make it. May I please ask for one big final round of applause for all of our amazing Blue Stamp students. Thank you guys all so much for presenting tonight. And good job to everyone coming in. We have facilitated the 1 hour time slot. Reminder to all of our students, we still have class tomorrow. We still have class tomorrow. Come in. We're going to make sure you guys get connected into our alumni LinkedIn group. We're going to be taking our class photo tomorrow. We're going to be doing our final sort of competitions and reflection. We'll be handling all of your final documentation. We still have lots to do in tomorrow, so please make sure that you come on in. This was an absolutely awesome, amazing experience. To all of the stakeholders, thank you so much for being able to make it as well. The other room also finished around the same time, so you guys might have seen people coming on in to come on in. But thank you all so much for an amazing, wonderful evening, and students will be finishing things up tomorrow. I will hand it off to our co-CEO, Dave. Do you have any final words you want to say?
No, just that I am so proud of all of the work that's been done and the projects that have been built. They are going to come in so much handy when you look to move on to your next step. And that's something I always like to remind all of our students and families. We are here to support you as you reach that next step. So if you're looking for college recommendations or if you're looking for advice on where to go or things that can be done, please reach out to your instructor, to Everest, even to me. We love to see our students thrive. So please keep in touch. Make sure you are always looking for the next big thing and keep building.
Absolutely. Thank you so much for all those kind words. Thank you all so much. I wish you all a wonderful rest of your evening. For those of you who still have a couple hours off of the West Coast, or for those of you who might be headed tonight, I hope you all have a wonderful time. I am closing out the breakout rooms now, but I will still be lingering in the main room for a little bit if there are any final questions, any final comments, or anything that anyone wants to say. So if I'll be there for a little bit, feel free to talk to me while I'm there. But I'm closing all the rooms.